There's quite a delay. There's like 10 seconds delay between.
It's on.
Oh, is it?
Yeah.
All right. All right, sounds good. So online, you can hear me. Can somebody voice back real quick, verify?
Yes, we can hear you.
Yeah.
Fantastic. All right, I have no idea how that didn't work and then suddenly worked, but we're good. So we'll go ahead and get started. So today's talk is on reviewing technical articles, and this is an on-ramp to providing good reviews. And this is sort of like, you know, you pay your taxes, right? Wasn't that Monday was tax day? So some of you might have got extensions and you go, wow, I'm paying federal tax, I'm paying state tax, I'm paying local tax. But guess what else you're doing? You're paying for uninsured drivers. You're getting house insurance, right? Property taxes, all these other things that go on there. And this is kind of like a hidden tax, right? If you want to be in a peer group, if you want to be part of a group like in COSI or IEEE or ACM or IS&T or all these other organizations, professional organizations, this is a hidden tax that you have to pay. You've got to be able to give peer review to your colleagues who are out there. And so this will be a talk on how to do that, some of the issues that you're going to come across, and some of the worries that you might have and ways of doing it well. And originally, part of this talk was presented at last year's Document Engineering Symposium in Limerick, Ireland. So you will see in Limerick form 10 terrible ways to do a review in each of the 10 areas that we're doing that in Limerick form. And so I want to also give some thanks to Alexandra Bonici, a professor at the University of Malta. She and I worked on the slides last year. These are predominantly my material, of course, because she's not doing the talk, but we did an extended version of this for a half day at DocEng last year. And so that's what you'll see here. So the motivation for this talk is, wow, if you look at this, it's a recursion inside a recursion inside a recursion, and you start to realize that the people who are doing reviews now are just the people who happen to have had reviews done on their papers and had their papers get into that professional organization. We need to do better, right? It's kind of like how politics is working now. We've got people who are politics because they've been in, maybe their dad was president and they became president, or maybe they have a lot of money, not qualifications that are out there, right? And so the people reviewing the very conferences that we're running now, or the people who are editing journals that we're doing now, are people who've published in those journals or conferences. And it gets a little scary because we don't want that to go on, right? So a lot of people are saying, oh, I'm not in position to meet the reviewing obligations. I don't have sufficient experience, or I'm interested, but I don't have experience. Really? Can systems engineering researchers, can systems engineering students conduct effective reviews? Spoiler, yes, you can. And you will be able to after this lecture, and you'll have the confidence to do that. Do you have the confidence? You do. You have the confidence, but you don't need this then. There's the door, right? You don't need this. All right, so these are examples, and I'll give 10 more in Limerick form, as I mentioned, but these are examples of bad reviews. These are, and you might think, oh, that's kind of innocuous. That doesn't look so bad, and I'll tell you why they're bad. So number one, even the authors could not clearly explain in the conclusion or the body what are the new results. The article is not suitable even for a poster, right? Since it is very early stage of the investigation, numerical experiments are not of sufficient interest for a research article. Notice what's in there. There's opinion. State facts. Don't state opinions. You might have your opinions. You might share with your buddy. God, that was the worst article I've ever read. Don't have that in the review, right? So don't have that in the review, and it's insulting, even the authors. So these are quotes. These are reviews we actually got in our own ACM sponsored conference over the last few years. Even the authors could not clearly explain. Well, of course not. You're reading their writing. That's like saying, you know, I'm going to say this out loud. Of course you are. That's how people say things, right? It's Department of Redundancy Department. So don't tell them that even the authors couldn't explain something. And again, try to leave the opinion out of that. Think about it, and we'll get to some rules around that. Number two, the authors apply some standard approach to some unavailable data set and produce some numbers. Where's the novelty? This is just a report on some work and is not a suitable paper for this conference. Okay, that's mean, right? You could say, hey, the data set is not publicly available. It will be hard for somebody else to repeat this work. Those are facts. Bring them into facts. Get your personality out of the review unless you're going to be friendly. Like say, thanks for submitting this paper. It's okay to do that, but don't have opinions about the review. And this one is terrible. Great paper, recommendation accepted, right? What does that mean? give them some feedback, right? They want to get that because they might have the other two reviewers say they're rejected. And you were the one who liked their work and now they have no information on why you liked it. The worst thing you can do is give somebody no feedback whatsoever. That's not feedback. That's just a binary check, you're in kind of thing. So those are examples and they don't look, these are not terrible. You're not like spitting out a whole bunch of swear words at them, talking about how badly they dress or anything else like that, or they have bad breath, halitosis, right? That kind of thing. So it's subtly bad. So let's take a look at the peer review process. And the whole reason why we do peer review is for quality assurance, right? You take pride in your work, right? You're a systems engineer. System engineers other than you should be good too, right? So get good. Feedback and improvement. We're trying to improve our field. So the feedback and improvement mean a lot. Filtering misinformation or flawed work. So filtering, not canceling, right? I ain't cancel culture. I'm not going to go there. It's about filtering. You filter stuff. What do you do when you filter data? Do you get rid of all of it? No, you selectively get rid of it. So that's important to remember. The paper may not be acceptable in the journal based on what the journal's, looking for, or in the conference based on what the conference is looking for, but you don't throw out everything. You're filtering misinformation. These parts need more information, they need more statistical relevance, et cetera. You're validating their findings, so it should be reproducible. And that's a really important part of that. And we'll talk about that. It is not important for you to be able to replicate their work as much as it is for you to disprove additional aspects of their work, the Popper, falsification method. And then, of course, an engaged community. If you're peer reviewing for the community, you're engaged in that community. Guess what? You've got a peer review group that's going to be engaged with you. And they're going to want to do the same thing for you. All right, so some of the author benefits, obviously, improve quality, exposure, recognition, validation, and credibility. But the reviewers also contribute to the field. They get recognition and reputation, and they get personal growth. And one of the ways to stay on top of a field is by reviewing. Because, man, you keep up on everything. Even if you don't have a student or a colleague or whatever working in the same area, you're seeing what other people are doing. You pick up a lot of, hey, so when somebody talks to me about this, they're like, yeah, I'm going to use TensorFlow or this or that for this. And you're like, yeah, I'm not seeing as many papers on TensorFlow lately. A lot more people are moving towards this or that, right? Well, how do you ensure it, right? So a rational review process for a conference or a journal. So don't sign up for a journal or a conference that doesn't have this, is a diverse pool of reviewers. We already know what maybe the experts in the field are. Let other people contribute. Reviewers have to be allowed some time. Right? Don't give somebody a review and say you've got a day to get this done or you got a week to get this done. Most people are going to need a couple of weeks or a month. You need a large program committee so the reviewing load isn't too large. And then again, post-review comments. Conflicting reviews are especially invited to discuss and revise. So have a rebuttal round if you can. And the rebuttal round's not as much necessarily for the authors as it is for mixed reviews. So if you've got a review that -3 is the worst, +3 is the best, and you get a 2, a -2, and a 0, those reviewers need to talk to each other, right? And then, of course, there's editor or associate editor oversight, right? So we actually have various levels. In all three of the journals that I'm an associate editor for, there's an editor looking at what I'm doing, and there's reviewers who I'm looking at what they're doing and vice versa. So you've got that kind of checks and balances that make sure there's a smoothing process for that. Let's get into responsibilities. So the reviewers, right? You have to allocate sufficient time to conduct a review. And does anybody print anything out anymore? Yeah, I print out my reviews because I want to make a lot of notes on those. It's one of the few things I still use a printer for because I find doing it on paper allows me to flip around, go back and forth. You possibly need to do that now, or you'll open up several windows on your screen with the same document. You want to be able to communicate with the editor or the program chair. So there has to be good interaction between you. Don't be afraid to go to the editor and go, I'm seeing this. Is this a problem, right? Respect deadlines. That's really important because, again, that's a person who's submitting into your area. They need to get the feedback when it is, acceptable for them. It might be tied to, like getting their prelim exam scheduled. It might be tied to their final exam, might be tied to tenure. So think about things that could be happening there. And of course, observe academic integrity, right? And so academic integrity is the same type of thing that you would do for a class where you say, I'm not allowed to go out and have somebody else do this work for me. So if you have somebody that you think is going to review, let the editor know. Because again, it is if you will, a breach of confidence, and anything that's handed in for a review is considered secret until it's either accepted or not accepted, right? And if it's not accepted, it's still secret. So it's almost like intellectual property law, right? Somebody has the right to that data not being shared outside. So you can't just go give it to somebody without letting the associate or main editor know, or you're breaching that. And then, of course, on the other side will be the program chair or the editor, and they will select appropriate members for the program committee or the reviewer pool. They will also vet the reviewers thoroughly. So if you've got a reviewer who, for whatever reason, let's say you're doing something with, I don't know, autonomous vehicles, and the person that is reviewing for this has their own particular view on that, right? Maybe they're from one of the manufacturers or whatever, and you know that every time they do that, they're going to be biased towards their own thing. You don't assign them reviews in that anymore. Even though they're qualified, you give them something more where they can be a little less biased. And of course, somebody is supposed to report if they've got a conflict of interest, and then select papers that obviously add value to the conference or to the journal. So we get into those limericks. You can read the limericks yourself. I'll see a few of you doing the little limerick lilt on the side. Those are bad ways to give these reviews, but these are 10 things to look for in a review. And so I charge you, all of you here are qualified to make a review in your area of expertise. And so these are the things that might help you make a better review. So the first thing is you want to frame your review how you would like it framed if it were your paper being reviewed. That's called empathy, right? And so think about it. It's easy to think this is just a piece of paper. There's a name attached to it. There's actually a person behind that name. And we forget that sometimes, right? And how many of you enjoy, first off, we enjoy getting constructive criticism, right? It's really fun to get constructive criticism, even if the paper is rejected. Because then I can talk to a student, or if it's my own paper, I can talk to myself. Steve, how you doing? That's okay. It was a good review, right? So those work out okay. But the point is when you don't give them something that you yourself would want to receive, it's probably going to be taken poorly. It might make them cry, right? Might make them go out and purchase something stupid, right? From your competitor. So think about how you're actually making this work. There's a person behind it, but don't be sappy. Don't be sappy too. People can tell when they're patronized, right? How many of you have been patronized sometime in your life? And you're like, oh, I'm just here because, I'm wearing the sweater, right? That's the only reason I'm here. People are like, we need somebody there in a blue sweater. We all know when we're being patronized. Don't do that, right? All right, number 2 is emphasize the good. So think about this, right? There's 2 ways of going through life. You can be that kind of person who looks at others and just picks them apart and says, you're not good at this, right? And so you focus on their weaknesses, right? So what do? You get that person to continually focus on their weakness. They're sitting there trying to make what they're not good at better. Or you can be the second type of person who says, I'm going to look at what's good in this and have this person push forward with it. And guess what? If you take your strengths and you continue to move them forward, all the weaknesses follow in its wake and they cross over this good line. Right? So think about it. Do we all know somebody who's really sensitive to feedback? We all know somebody who's kind of, right? You're laughing. You've got someone in mind. You got somebody right in your head, right, already. So we all know people like that. The flip side of that person is they're the canary in the coal mine. They're going to be the person who tells you, hey, that's just not right. They'll see an interaction between 2 other people. So do we really want to knock that sensitiveness out of that person? Or do we want to take the good and say, we need you to be the kind of person who tells us when the organization has these kinds of flaws? Of course we want the latter, right? So emphasize the good, because if you emphasize the good and the person pulls their good along, all of the bad comes in the wake and gets better, right? And that's what we want. So most papers are going to be cited later for the single, maybe 2 sometimes, biggest ideas they contain. Find that idea in that paper and go, that's what I want. Wait, so you might say the paper is not acceptable in current form. That's okay. Review, a lot of journals have very low acceptance rates. And I think, what is it? ICVP is, the International Conference of Visual Recognition. What is it? One of the IEEE ones has like a 3% acceptance rate. So going in, you don't have a great chance. But if a reviewer tells you this is the kernel idea, oh, and by the way, this journal has a 30% acceptance, but this paper is going to probably get in that journal, that's really helpful too. So find out what's the good is. Everybody can figure out what the bad is based on what you don't talk about in the paper, right? So have that come later. and say, this is, I think, your main idea. Expostulate on what you think their main idea is. So I would go in and shore that up, get more data for that, more background. And again, you want to make the paper readable and improve all its aspects. You can give them feedback on, I mean, you'll occasionally get one of those grammatically challenged papers where literally every sentence has a typographical or grammatical mistake, and you're just like, oh man. So just say, look, you get somebody, a friend who's really fluent in this language to go read it through you. I'll give you an example on the first paragraph. I'm not going to nitpick the rest of the paper because nobody needs 10 pages of that back, right? We really help the authors develop that core differentiating contribution. And you know what'll happen? Is everybody who does review for that committee, and again, it's your peer committee. These are the people you're going to be building your career with, right? And I've changed my career many times. I was with NASA, I was with HP, I had 10 different jobs in HP. I've been here as a professor, but my professional organizations have carried along with me. IEEE, ACM, IS&T, now in COSI, right? So you look at those types of things and you say, that's going to carry with you. This is something that anchors your career, even if you make changes, right? Nobody leaves a job, right? They all leave a boss, and you're going to get a bad boss someday. Right? And so you're going to go, I need a new job, right? But you'll have these to anchor you. And so help that author develop the core differentiating contribution. You know what'll happen? You've got this whole amorphous area that you're in, and you'll start building specialists for each of these areas, and you'll have your own special area that they're helping you build, and you'll all move forward together. Right? Really cool. So emphasizing the good is a big thing. Number 3 is background research. And this is something I think a lot of people forget about the reviews. And one of the journals that I'm a associate editor for is run out of Ohio State by Hojat Adeli, and what he tells you is don't look for your own papers that are missing in the review. And you might find some one time that's really obvious, and you're like, oh, I was pulled in to review this because it's a follow-on on my work. It's okay then if they're missing that, but go out and take like the most differentiating terms in the title or the abstract, search them on Google Scholar, and see if 1 or 2 of those articles that come up on the first 10 out of Google Scholar are in the references for that paper. If they're not, it's like, have you really reviewed this? And you'll notice this too. You'll get like a lot of people really just getting into grad school or whatever, and they've got all of their papers are from 2023. And you're like, wow, this field just magically appeared in 2023 and nobody did any work in it before, right? So you're like, okay, make a suggestion there. And that's really important because they will actually get better references if they've anchored themselves in the references that are important in that field. And if they're missing all of those, and we'll see this a lot of times, you'll get regional bias. You'll have somebody from the US or Canada, and all the reviewers are from US or Canada. Somebody from India, they're all from India. Someone from China, they're all from China. And you're like, this is a world. Think outside of just your own little area. And so you can do that. And so see if they've included them and give it back to them, right? All right. Number 4, plagiarism starts at home. Wow, is this a big topic nowadays, right? Huge topic. Everybody's doing this. People are starting off with ChatGPT, and then they're not actually bothering to turn it into their own language. Now, it's okay to go use AI to see what AI is telling you is the baseline, but you could go to Wikipedia for that, right? Or you could go to Google Scholar and read the top 2 or 3 articles. So ChatGPT, if it's used like Google Scholar, Google Patents, or Wikipedia, right? And we all know Wikipedia is hilarious, right? You go out to Wikipedia in an area you really know. What do you see on Wikipedia? You're like, what is this, right? It's a little bit scuffed, right? But so is, by the way, so is ChatGPT. And when ChatGPT comes up to an expert in the field, the expert's like, this is superficial. It's sort of right, but add to it, please, right? And plus, 0GPT and GPT-0 are going to find out instantly that you use that if you don't change it into your own language, right? So those exist. Look for some of the rarest terms in the paper and search for them on Google Scholar. And if you want to use a plagiarism detection, give them feedback and go, it does appear that this was done by an AI. We're okay that you used AI to kind of make sure your context is right, but you need to put this into your own words and integrate it into the rest of the paper, right? So plagiarism is actually something we need to do as reviewers, like it or not, right? And I got news for you. You're smarter than ChatGPT in your area. You're going to write a better paper. So tell that author the same thing. They may not be aware of that. Number 5, is it reproducible? And we've talked about this before. You want to go into the reviewing intending to replicate their experiment. And if you take that approach, it's actually easier to get through the paper sometimes, right? Because we've all been there. There's a paper where the materials and methods are such a slog. Like you're like, wow, there just isn't enough Guinness brewed in Ireland to get through this review, right? And so when that happens, what you do is say, can I replicate this? Start going, oh, I see how to do that. I see how to do that. And you know what it'll do? It'll help you as a reviewer because now you'll have learned a new methodology, but you can also give them feedback and say, this is not reproducible, which means it's not helpful to science. So can you do it from their instructions? Can you do it from whatever they're doing? And don't just say, oh, I can't do this in my lab because I don't have a license for this software. It's like if you had a license, right? So there's some give and take there, right? All right, so number 6 are the materials and methods, right? And what you will do is you bring a lot of expertise. All of you have spent some time programming, analyzing, modeling, simulating, or actually getting your hands really dirty and being in the lab, right? So one of the things that you can do for them is say, wow, I've actually had this experience, and maybe you want to add that to your materials and methods. Here's where you actually can add from your own experience without being, I don't know if narcissistic is the right word, but without shoving your own references down them, and just go, in my experience, I've done these types of things in the lab. So somebody's doing surgery on an animal and they're, tearing open the whole leg to do something. You go, actually, I've done this before. It's laparoscopic. You put a little, depilator, hair removal on here, and you pop through here and you crush the sciatic nerve if you're doing an osteoporosis model. It's literally, the surgery should be that small of an area, not the whole leg and everything else. What are you doing, right? And that might point out a paper that you've got with that method and material, in which case include it. Right? So that's how you include your work, if it improves their methods and materials and they're not doing it the right way. Right? And a lot of you will do that. You'll go through this and you'll be like, I could do this a lot faster with some way. So you're helping them out too, because they're going to come to the right tools. And again, you don't want to try to identify yourself or push your own citations, but don't omit something. So don't also be self-sacrificing, right? So don't just push your papers on them, but if you know you've done something better because you're really investing in their materials and methods, you want to do that. And then suggest any relevant third-party materials and methods that are missing. So that's really important. And if they've missed a step and it allows you not to reproduce it, you'll either recognize that from knowing it yourself, or you'll be like, I can't imagine being able to do what they're doing out there. So the materials and methods are often overlooked by reviewers. A lot of people gloss over it. They're like, let's just get to the results and the conclusions, see if I agree with their conclusions. Materials and methods is actually, in a lot of ways, the anchor of the paper. And most papers, most citations are actually for materials and methods, ways things are done. So like one of the ones I've talked about in a previous talk, talking about how to do reference managers, is using the Lowry approach, which basically is just shining light through a solution to see how much protein is in there. It's been cited 200,000 times. It's a method and material, right? So the papers with actually the most citations are process or method types of descriptions, and you're helping them a lot by doing that. All right, number 7, are the results believable, right? And this is harder and harder to ascertain, especially with AI, where they're like, I don't even know what they're doing. And I'll be honest with you, if I see a paper that comes in and they're just using an AI to get some results, the paper's rejected, because anybody can do that, right? AI's out there. So they're like, oh, I spit this data in, I got this data out, there's my paper. It's like, no, that's not. The AI is a tool, it is not a paper. So AI is no different than what I just talked about, a Lowry method, where you're actually measuring how much protein's out there. So is the data credible? In addition to the value, is the variability provided? So I was in a SAMD talk yesterday, which is our material science group, and they do annual reviews for all their PhD candidates. And we'd asked the individual to improve the processes they're using since last year. And they showed a coefficient of variance on one of the material properties was like 0.05% or something there. It's like, you nailed it. And it was the variability that mattered there, because they were actually showing significant differences, but the variability was so tight. We're like, that's what you base all of your future work in this area on, because you have a process control that really works. So look at that. Look at which data is more credible. Don't just look at the mean values, the value, look at the variability as well. And is it an N=1 experiment? Hey, my Uncle Bob said this works, right? That's an N=1. How many degrees of freedom are in N=1? Anybody know? How many degrees of freedom are there with an N=1? 0. Deb's right. It's absolutely 0. There's no degrees of freedom. Right? Degrees of freedom is always 1 less than the sample in any group. So you have no degrees of freedom. It actually means it's a constraint, not a result. And you're welcome to use that comment. I've used it before, tried to be nice, but it's like an n=1 experiment is a constraint, not a result. You're not getting anything. Did they set it up for analysis of variance, or did they just use t-tests and z-tests? Did they check to see if the data was parametric versus non-parametric? You use Kruskal-Wallis instead of ANOVA if it's non-parametric. Those types of things are, I wouldn't say easy to find, but if you're here at CSU and you've got issues around statistics, we've got a statistics group that will help you. It's an on-campus resource, right? And of course, if you've got anything on that area, I know I will help you and many other profs too. Anybody who's teaching an analytics class, if you've ever got a statistics question for your experimental setup or your data, you can feel free to run it by me. So I'll probably regret saying that, but it's all good. Okay? So that's actually important. Are the results credible? Look to see if it's just a one-off, right? Because a one-off is actually worse than no results at all. Because it's something happened once and they're reporting it, that's a phenomenon, it's not an experiment. So you can tell them it's a phenomenon or it's a constraint instead of an actual experiment. Very dangerous because we don't want people basing it on that. And if you've ever read books like Stephen Jay Gould's Mismeasure of Man, what he did was just looked at kernel experiments in areas and followed them all the way back to the original data, and the original data was absolute rubbish. And so we're basing a lot of societal decisions on data that has no actual solidity to it whatsoever. So be really careful about that one. Then we get to the discussion, right? So the discussion should include one or more observations of things they might have tried. You're being asked to be a reviewer because you have expertise, peer expertise in that area. This is where you get to show it. There'll be one thing in there that you're like, did you try this? And they can always go, yeah, I tried that. I just left it out of the materials and methods. It's still, they'll add it to the next version of the paper and it'll make that paper better. And I always look for, and again, this is a systems engineering bias, but I always look for some form of sensitivity analysis to give broader perspective. Did they try a range of possibilities in an area? And in that range of possibilities, did they eliminate subdomains, from the input? And so that's actually really cool. And it's a great question to ask somebody. Just come back to them. Like if you got nothing else in the review, like you went through the previous one and you're like, can't think of anything in the materials and methods, anything in the experiments that they might have done. You're like, hey, how sensitive it is to these different parameters. And then they'll really understand their, what science they've produced. And again, look for, no overfitting, right? Look for tight coupling between the experiments and the discussion. And what I've seen often cases is that a lot of authors, I won't say it's a majority, but a lot of authors already have in mind what their discussion is going to be, and they're going out to do experiments to focus on that discussion. That is not science. Science is setting yourself up for failure in the experiments you run. They're supposed to cause your hypothesis to fail or to iterate, to change slightly. That's how we advance, right? So look for tight coupling there. And then adjacencies, right? So as in real estate, it's all about location, right? How close is your work to other potential applications? And potential applications are really important. It's part of being creative. And all scientists and engineers can be creative, right? You're creative, right? You're a creative guy, thinking I got creativity. Another chance to show it here, right? So you look for other potential applications because a lot of papers do not, just like most intellectual property, right? An inventor, most of the times when people come up with a paper or they come up with an invention, it's not the best idea the first time through. How did they iterate through that? And here, as a reviewer, is where you can add the most to science, because if you can take something that's brilliant work, but it's applied to the wrong area and you redirect them, all of a sudden that brilliant work is making society better. That's what we want. And then will it last, right? What will deprecate or obviate the reported findings? How long is it going to last? So if you're swimming along in 2012 and you're doing, support vector machines and Bayesian conditional probabilities and other types of things like that, and you're like, I got image recognition solved, all of a sudden, AlexNet and GoogleNet come along in 2012. Convolutional neural networks and other deep learning absolutely blow away everything you've done, reduce the error by 95%, and it's completely antiquated overnight. And that happened to a couple of friends of mine. I'm like, man, that just destroyed my whole PhD. And I'm like, no, you're just going to have to incorporate this and show that what you were doing can't compete with convolutional neural networks. But it does hurt, right? And that happens to all of us, right? Something we've really treasured, was really brilliant at the time, we thought, is obviated, meaning made, redundant or deprecated down the road. But that's okay, because science actually is framed on falsification. Karl Popper's falsification principle is part of any good experimental design. So if you hear somebody tell you the goal in your dissertation is to come up with a hypothesis and go get data that supports that, run screaming. That's bad advice, and that's not how science works. What you actually want to do is set up experiments that can falsify your hypothesis so that you learn from it, extend it, alter it to what's going on there. So do the same for these folks that you're reviewing for. Are they setting themselves up to test the hypothesis meaningfully, or are they just looking, selecting, filtering data in to support it? That's the wrong way to do it. And also anyone can selectively find evidence in support of a theory. Anybody know what that's called? That's called an echo chamber. We've got that out on the internet. So try the experiment. I've done this. Come up with the most ridiculous thing you can do, like sentient carrots. And there's a group out on the internet that believes in that, and that will support your findings. So we know you can find something in those sentient carrots. Man, that's going to change it. You're not going to eat vegetables ever again, right? So if there were sentient carrots, don't you think the rest of the world would support you? You can always find an echo chamber. Don't take what we have from the internet, the bad baggage. There's tremendous good from the internet, of course, but don't take the bad baggage from the internet and apply it to science. That's just bad science. Don't echo chamber your own work, and good reviewers will notice that. You'll be like, hey, you're just finding data that supports this. What about this stuff? What about this stuff, right? All right, so those are the big 10. And then we get to the point of writing the review. What do you actually do to provide a review? Because some of you are probably going, are there any folks in here who have yet to do a review for a journal or a conference paper? Don't need to be shy. Any hands? Couple. So there's a couple in here. So it's easy. You read the manuscript once in its entirety. Just read it through. Don't try to worry about taking notes or anything. You might see a couple of places where you're like, I have no idea what this is saying. Circle that and come back to it, but you read it through once. Because sometimes authors, like speakers, are waiting for the best stuff later in the paper, and they forgot to put it earlier, and you go, hey, you might want to put that right here because I had no idea what was going on, and then later I did. So then reread the manuscript and take those notes. So it does take 2 reads, right? And if you get a 10-page document or a 20-page document, yeah, it'll take an hour or 2 to read through it. Then the second read will go more quickly. Write it clear and constructive. This is really hard. It's got to be constructive, not destructive, no matter how much you disagree with them, right? And it could be bad stuff. It could be like, you know, something in sociology that you completely disagree with, right? But write a constructive review, right? Then make a justified recommendation. So justified means it's supported by data, by facts. List facts. And it's going to have a bigger impact on them if you do that. You might hate the person who's doing it, right? Because there could be some, I've read papers before, I'm like, what is this? What, you know, rock did this person crawl out from under, right? But you're like, you can't say that in the review. You can say it to your friends. Then take a step back and review your own review. So that is omphaloskepsis, right? Staring at your own navel. Is your review something you would want to receive? Go back to those first rules and say, all right, I'm honoring this person. And most people whose papers you're going to review are not objectionable people. But let's just say this person really bugs you. Still, would this be something you would want to receive, assuming you got it in good faith? So that's your process. It's fairly straightforward. And these are examples of like a framework you could use for review. So again, these are facts. This paper discusses this. The main contribution is this. Notice the main contribution. Work on the good. And then I recommend, this is your recommendation. So that's a fact as well. Your recommendation is a fact. It's not an opinion. It's something that you have come through. We're trusting your review. And you say, I recommend this, this, or that, right? It's either accepted, rejected, or borderline. And you can come up with something in between. And then you give reasons as your major comments. And like the statistical analysis is unsuitable because it's using parametric statistics where it should be non-parametric. Or the data is insufficient for us to make a statistical inference. Those are good examples. The methods section clearly does not explain those methods that you came up with. And some of the fundamental or recent papers in the field are not cited, including these. And I would like to see, so this is telling I would like to see some discussion of the findings of these papers in relation to these other recent findings. That's also a fact because those papers exist and you, as the reviewer, have determined that they are relevant to this discussion. And then finally, give some additional comments, but again, try to keep those non-opinionated. In several places, you've used the term this, but it seems you mean this. or in some of the figures, the legends are too small to be legible. And another one you'll come up against is that people will be referring to colors in their legends. And 8% of males and 0.5% of females have color challenges. So that is actually not equitable. So go, hey, you're talking about red line versus blue line. You might want to make one a dashed line and one a solid line, because that'll be more legible for people. And also not even color challenge people. Somebody might have printed out on a black and white printer and they can't read it. And then on page, the very fact, it is stated that this, but the paper by this states this. Can you comment on this disparity? Right? So you're just saying it's a disparity. You're not accusing them. You're wrong, Smith's right, but you're saying it's different from what this paper, which has already been published, has stated. Can you comment on that? And that'll give them a good idea. It's a nice way of saying, you know, you missed this without having to say that. So those are good examples. And again, this can incorporate everything you've got in there. So you might say, you know, that kind of covers it up. So to recap, right? To paraphrase Tolstoy and Anna Karenina, right? So everybody's read Anna Karenina, right? It's a short read, a couple hours, right? You're done with it, right? And it's really engaging, right? So if you read Anna Karenina, Tolstoy basically says every good family is good in the same way, but every bad family is uniquely bad. And that's kind of how it is with reviews too. You know a good review because they all kind of look the same. They all kind of look like this. They've got, you know, stating the facts, everything else, but every bad review is bad in its own way. And we saw some of those. And some of those you're like, wait, that person said this is the best thing that's ever come out of science. It's a great paper, accepted. No feedback, right? That's not helping. There's no actual constructive feedback. It's just praise, right? So praise is different than feedback. Critical reviews are not bad reviews. This is important. You can criticize somebody's work, especially when it's wrong and you know. That's why you're the reviewer. And executed properly, peer review can be a teaching experience both for you as the reviewer and the person who's reviewing it. And then the top 10 things for a review provide a framework, but they're not enough. You're going to have nuances and you're going to go, wow, Steve gave me these top 10, but I didn't see this coming in the introduction where they're like obviating a whole area of science. Oh, but I'm equipped to do that. I state the facts. These other papers don't say what you're saying, etc. Right? All right, so with that, I'll open it up for any questions that people have, and hopefully we've got time for that. Supposed to end at around 1:45, right? Am I good? All right. If anybody's got questions or comments. And again, I did a quick, you know, napkin type thing. I've done at least 3,000 reviews of technical papers. And when we were at HP, I probably did 50 to 100 every year just for the internal conferences. So I don't even know how many thousands out there. But again, it does make you proficient in areas, maybe not the best person in an area, but you can talk with some degree of proficiency to pretty much anybody in the area that you've reviewed in. So it'll make you smarter if you know how to do a good review, right? All right, questions? Any comments or questions?
Ask a question?
Yeah.
Okay, so I was in the exact situation of the first comic that you posted, to where, you know, I kind of got an invitation to review for a conference that that my paper was published in last year. And while the paper is technically in my field, it seems like, after looking it over, it seems like something like it just looks like Chinese to me, and I don't speak Chinese.
Understood.
In this case, I still have to review it, but it seems as though, you know, there's an upper bound on the amount of time that you do want to spend teaching yourself things so that you can understand what they're saying, if that makes sense.
No,
and I'm curious as to how you balance that.
Yeah, so I would let the associate editor who assigned that paper to you know right away and say, is it okay? My background in this area is fairly rudimentary, but you can read through a paper and you can tell whether it helped explain it to you. And it still may be, you know, a little bit obtuse to you, or maybe area you'd have to invest in more to understand all the nuances, but does it convey it to a generalizable enough audience? And the thing is when you publish a paper, even though it is in a specific journal, it's in a specific field, it does need to be broader than just its specific field. So it needs to be anchored somehow to real life. So you would still provide good input, but if the editor is looking for more specific knowledge of that area, let them know right away. And of course, one of the things you can always do, most journals and most conferences will give you the abstract to look at to say whether it's something you feel you can give a good review on, right? And so you know, for me, if I see the topic is something that's fairly controversial that I don't think I'm going to be non-biased about, I go, no, I'm not going to take this paper. So, and a lot of times they'll be looking for people anyway, because there'll be another person like you, good spirited, trying to help out, trying to take this on, and they got a paper they can't use either. And so if you send that back to the editor, they'll learn. And one of the things we learned in one of the conferences that I work on is we needed to add another reviewer to the reviewer list, because we always ended up in the mean with about one reviewer who really wasn't knowledgeable in that area. And so we ended up reassigning them. But that way, if we dropped one person, we still had the 3 reviews we needed. So yeah, I would push back. You can always go back to the editor or the associate editor, whoever assigned it to you, and say, this is the caveat here. This is not my area of expertise. It's Chinese to me, and I speak Japanese, or whatever, however you want to put it. But come back to them and let them know that's the first stop on that, is letting the associate editor know. And then they might have, oh, you know, I'm doing 7 or 8 of these. So like the journal I was talking about before, ICAE, the Integrated Computer Aided Engineering Journal, we typically have 8 or 9 reviewers for every paper. And we understand that 2 or 3 of them are going to be like, and not have any idea what they're doing, but they're going to give you feedback on whether the materials made sense, whether the paper held together, et cetera. And we hope that the 4 or 5 who are actually really good at it are going to give us the technical feedback that we need. So again, a surfeit of an excess of reviewers often allows a reviewer who's not as specific to the field, but is generally educated and intelligent and knows good writing when they see it, to still provide good feedback. So I would check that with the associate editor. Great question. Thank you. Did that answer all of the aspects of that for you?
Yeah, and if it's possible, I guess I technically have one more with regards to the same
go ahead.
situation. I just don't want to intrude on anybody else who might have a question.
Go ahead. Go ahead.
Okay.
You might stimulate somebody to ask one who was too shy, so it's all good.
Okay, so because for this conference, they give like a few months to review. So they give you a long time to review it. But I technically didn't really look at it until, you know, maybe a lot later than I should have. But in this case, would that be common for somebody to say like, hey, you know, I looked at this paper now, is there a way I could potentially review another one? Or because it seems like if the process is far enough down the line, it's very likely they've already completed assigning papers to individual people already.
Yeah, and most of them will have completed that on day 1, right? So we use Easy Chair for most of the conferences that I review for. I maybe review for 10 a year or something, and most of them are on Easy Chair. And so those are all done at once. You're not the first person in the world, believe it or not, who waits for a deadline. Anybody else? Right? So, I mean, they know how to expect that. And actually, for what we've learned in the document engineering ACM conference, is we have a week there for those of us on the program who are program chairs or steering committee chairs or whatever. We'll have a week between when the reviews are meant to come in to actually go in and do emergency reviews of papers. So that's kind of on their end. It would be helpful if you look through it real quickly, triage them in the beginning to say that. But again, if you haven't done that, most conferences understand that and they'll come back to you. And so ICDAR, which is the International Conference on Document Analysis and Retrieval, I am not on the program committee or anything, but I am a reviewer for them. And they'll come to me usually like with a week in advance and go like, oh, we didn't have reviews for these. Do you have time to do these, et cetera? So they have a process. It's not ideal, but you're not like, it's not entirely your fault is what I'll say if they don't have a process in place for that. So don't feel too badly about it, but yeah, I mean, learn from it, go forth and sin no more type of thing, and try to, at least triage them down the road, read the abstracts and go, I got no idea. And you can just hand it back to them with more time to respond. But in most cases, they don't actually have a process to respond to until the reviews are due anyway. So it's probably a very minor problem there.
Okay, thank you.
Yeah, thank you. Marie, yeah. So Marie's asking, for those of you online, in case you couldn't hear that, about conflict of interest. What if you get a paper from somebody you don't like, right? They've got BO, right? They got body odor, they got halitosis, they scratch themselves, or they're just bad scientists, right? So you've got some reason why, or there's somebody who's got a competitive theory, which you feel you have supporting data that shows they're wrong. let the associate editor know. That is definitely a situation where you're like, I can't do this because of conflict of interest. If I see that, and I've got, lots of colleagues in certain areas and I get assigned their paper and I'm like, nah, I'm probably gonna approve them because I like them and it'll be in the back of my mind, you need somebody else. And so Easy Chair does allow you to declare conflict of interest on all of the papers when you're triaging. Most good conferences will allow you to go through and declare conflict of interest, something like that, declare it right away. If it's not that well organized, and I know you're alluding to one that wasn't, if it's not that well organized, it's okay to push back on them and say, caveat this, if you don't have somebody else qualified to read this, I, in general, do not agree with what they're trying to do. And so that there may be some unintentional bias in there. The fact that you can recognize that and tell that to the editor is actually much better than not reporting it. It's a lot better than not reporting, because guess what? They're going to have several reviews to go from, and they'll go, well, actually, Marie said she was biased, but she gave the best review out of the three. Gone, right? So it'll actually be helpful if you've already told them you've got that bias, and it'll surprise you, maybe. But a lot of times, if you don't like somebody, other people don't either, right? There are people who are unpopular because their views are whack. And so if you are actually honest about that and you've given the best review, you've actually done more damage to that person you don't like than by being mean to them behind the scenes and not acknowledging it. It's a weird thing, right? But if you really want to do harm to them, you admit up front you hate them, right? Because then the editor is going to know that and they're going to see everything else, right? And I know you don't want to do that, but I'm just stating the point. Honesty is always the best policy in these types of things. We're really counting on honesty for peer reviews because remember, they're confidential, right? So it's a tricky situation. You can't go to a friend and ask them about that. You have to go to an associate editor. There's a limited amount there, so you got to keep that line open. So I would just go right back to them right away and go, just so you know, there may be some unintentional bias in here because I don't agree with these people in general. So let the associate editor know it's their problem, right? And I get that all the time as an associate editor. Somebody will tell me, just so you know, I don't buy into what this person's doing at all. And then I look at their review and it's like all 10 of those steps we talked about, specific facts pulled out of the paper. It's like, okay, they're biased, but the review is perfect, right? Because the review is absolutely accurate, right? And a lot of times we do that. It's a weird thing about human psychology, right? And there's probably a psychologist in the audience who can point this out more. We actually sometimes are overly fair to the people we dislike the most because we want to make sure that what we're saying is justified so that we're not actually showing that bias. And so surprisingly enough, you might give really good in terms of constructive, fair, equitable reviews to the people you dislike the most, right? Just because you want to make sure you're not being that guy, if you will, right? Great question. Thanks. Anyone else online? I think it looks like there's a hand up. Maybe Kenny.
Yeah, can you hear me okay, Dr.
I
Simpson?
can. Coming in
Awesome.
good, Kenny.
So I had a quick question just regarding dealing with, say, like an interdisciplinary paper where there's more than one topic area, and say you're familiar with one of the topics or one of the areas in the paper, but not quite familiar with the other one or the other couple. Like, how would you typically handle that scenario?
Oh, that's okay. So you've got domain knowledge, and that falls in really nicely into the example I gave before, where there's a excess of reviewers for a particular area. What they'll do is the associate editor, just let them know, and you don't have to go back to them on this. Just say, thank you for submitting this paper to this. My expertise is in this area, and I will focus on that in my review. And so do that focus, but then say the rest of that seems to connect to it or doesn't seem to connect to it well, but you're reviewing the parts that you know really well. That's going to be a very helpful review. Because it's okay, because if they can't integrate the parts that you know really well into the rest of the paper, it's probably a bad paper anyway, right? And so you'll actually be able to do a pretty good review there as long as you have a deep knowledge of a big chunk of the overall work. But it's okay to have gaps in there, and you can just admit those up front to them and say, I'd really like to see more about how this connects to these parts because this didn't make as much sense to me. I don't have as much background there. And most reviewers, certainly for conferences, they'll have a reviewer proficiency. So like for DocEngs, we have it going from 1 to 5. And if somebody says they're proficient at the 5 level, it's like, okay, they know the whole review. You might go in there, Kenny, and say, I'm a 3 or a 4. And it's okay. And we've got people coming back with like a 2. They're like, I know some areas, but then you just look at the quality of the review and they're like, yeah, everything they said. Because remember, the associate editor is supposed to understand how to pull those together and has read the paper themselves. And they go through and go, yeah, that's absolutely factual. So just report that area. And if you have a chance to do it, if you're going through like EasyChair or some other online type of thing, it'll usually have a proficiency mark for that. Just mark that down a little bit. Don't say 5, say 4 or 3.
I appreciate
Other
it. Thank you.
questions? Oh, yeah, thank you. Oh, please. Yeah. Oh, okay. So the question is, if I'm a reviewer who doesn't have proficiency in all the area, and I think the paper is really, really good, is that harmful? Not at all. Yeah. No, you can have positive comments, but they need to be specific. So if you have, and we're going to get papers like that, right? They're wonderful. You get a paper and you're like, wow, this is really good. But you point out why, and you just say, this is really good because it tied it into this field. This data is credible. You went back through, repeated the experiment, got the same exact types of results. You can give all of those things because that'll help the reviewer to, the associate editor or whatever, to put it out there. And it will also help. A lot of journals will decide which paper to market. And if you've got those types of comments in there, they might decide that'll be the paper that's featured for this issue. And they'll use your comments to kind of give a short, summary of what the paper is. So even if it's all positive, as long as it's constructive, you're saying so constructive means you're building. So you say, this is what the paper built, and this is what I see it having built. That's constructive criticism, even if it's positive, right? So remember, criticism itself can be negative or positive. It doesn't have to have an affect, right? So great question. Yeah. Okay, any other questions? We got a minute or two left, right? Right about on time? 2 minutes. All right, if no other questions, thanks for being here. This is being recorded, so you'll be able to watch it forever. You can put it on repeat and just watch it over and over, reliving those limericks. Do, 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 do. All right. For the limericks. All right, well, thank you very much.